We've all probably gone to the fridge, pulled out a Gatorade just like this, and popped the top and drank away when we're thirsty. If you look at Gatorade's logo, and their catchphrase for many years has been the thirst quencher. It's all over their packaging. Well, today we're going to take a closer look at what the ingredients are and what the chemistry is behind Gatorade and how that applies to what we're learning this week. If we take a look at these main ingredients for Gatorade, we see this term that pops up, and you've probably heard Gatorade talk about it before. These electrolytes, your body needs electrolytes. Electrolytes. Well, what is this? Well, electrolytes are basically ionic compounds that get dissolved in water, and they can create an electric current. And your body needs this for several functions that we'll talk about later. But now we're going to get into the chemistry of what happens when these things are actually dissolved in water, uh, and and looking at these ions specifically.
All right, so let's take a look at those Gatorade ingredients and let's talk about what an electrolyte really means. So I'm sure you guys remember from your health classes that the first thing listed is always the number one ingredient, the most abundant. So the number one ingredient for Gatorade is water, and we've been talking about solubility, things breaking down and dissolving water. Well, one of the other main ingredients that is in Gatorade is salt. And I'm sure that all of you guys know that that is sodium chloride. If we're talking chemistry, we are talking chemistry after all, right? So what's going on when we mix together this salt into the water of Gatorade? Okay. Well, this salt, it will mix with the water, but it will break down. Okay. And so when it breaks down in that water, we're going to say that the water is going to stay together, but it will dissolve and break down these into their different ions. Okay. And then the water will be by itself, floating around. Later on, we're going to take a closer look at water, but we're taking a look at these ionic compounds. And so if we take a look at this, what is happening? Well, if I had 1 mole of sodium chloride and we dissolve that in water, I would get 1 sodium ion, and I would also get 1 chlorine ion. Okay. And so what does that mean? For both of these different ions, we'd have a 1-to-1 ratio. So 1-to-1 for all of those. So for both of these ions, there would be an even amount of each one. Okay? But if we take a look at another one of those ingredients in Gatorade, it was called sodium citrate. Okay? Which its chemical formula is Na3C6H5O7. If we take a look at this, well, you guys should know that sodium's charge is a +1, but how many do I have? So really, this has to be a +3. So this is a -3 charge. Okay. Well, what does this do? This is going to be in water as well. Okay. And so it will dissolve and it will break down, and it is soluble in water. So over here, we're going to get sodium again. Will come over here by itself. We will have the citrate, C6H5O7, and we will also have the water. Okay. But we're going to focus on these ions. Now, if you take a look over here, I have three of these sodiums here. So what does that mean I have to do over here? Well, that means that there's going to be 3 of those ions. I have 1 on this side, so I'm going to have 1 over here again. Okay. And so now we see that this ionic compound, when it breaks down in water, we get 3 times the sodiums that we would if we were talking about salt. Okay? And so this ratio for the sodium is over here I had 1 mole. This is a ratio of 1 to 3. I have 3 times the sodium ions floating around in that water. Okay, over here I have a 1 to 1 ratio for the citrate. Okay, so this is going to be important when we start now looking at, now I can start looking at these different ions, and if I knew their concentrations, okay, we can figure out how many, the molarity of these different specific ions. But basically this first section, I want you guys to understand this, okay, that when these ions break down, okay, they separate, they get dissolved in the water, and just the number of them on this side, if I balance it, if I have this written correctly, will separate, and we will have these different ratios. Okay, different ratios, different amounts. Okay, for the next part of this, now that we know those ratios, now we can take a look at solving for the molarity of those different ions that have been dissolved in that water. So first of all, we need to first solve for the molarity of the entire solution. So this equation should look the same as what we've done before. Molarity equals moles over liters. So I have 10 grams of sodium chloride, so I know I need to convert that to moles, and it's dissolved in 950 milliliters of water, so I need to convert that to liters, okay? So the first part is I'm going to take 10 grams of sodium chloride, and I'm going to convert this to moles of sodium chloride. I know that grams come down here, so that those can cancel. That's my units when I'm done. Okay, so if I look up the molar mass of sodium, it is 23, and the molar mass of chlorine is 35.5. So 58.5 is its molar mass, so 1 mole of that has a molar mass of 58.5. Okay, so if I take 10 and I divide it by 58.5, I get 0.17, so that'd be moles. So now the next conversion that I need to do is I need to take 950 milliliters to liters. So you guys should know 950 milliliters. I'm just showing you this if you have forgotten. Okay, 950 milliliters, 1 liter is 1,000 milliliters. So I would be dividing this by 1,000. But you should know we just take it and we move this, the decimal 3 places to the right. So it's 0.95 liters. Okay, so this is going to go on this spot to finish this equation. 0.95 liters. And I just left it in my calculator, divided by 0.95. And 1.79, I would make that 1.8. Excuse me, 0.18. And so that is the molarity of this entire solution, okay? So now let's analyze what we talked about on the previous section. If you remember, the ratios for how many sodium ions there were was a 1 to 1 ratio. So that means that we had equal amounts from when it started to when it got dissolved. So this is easy. The molarity of the sodium ion, which I can write it as brackets right here, is equal to the same molarity of the entire solution. So that is going to be 0.18 molar. Okay. Likewise, the ratio for the chlorine ions was a 1 to 1 ratio as well. So the molarity of the chlorine ions is equal to 0.18 molar as well. Okay, so these are going to be my 3 answers. Because they're both a 1 to 1 ratio, they're going to have the same amounts of these ions floating around in that water. Okay, we're going to take a look at the next one and we'll see how this is going to change. Okay, now let's take a look at the sodium citrate. So if we had 10 grams, okay, same setup. Now we're just looking at these different ions here. Okay, and if you remember from our other video, we knew that this was a 1 to 3 ratio, and this one was a 1 to 1 ratio. We might think that there's going to be 3 times the numbers of the molarity here, but we'll see how this actually plays out compared to what the sodium chloride was. So same thing, need to convert this to moles, this to liters. So I'm going to start out with 10 grams of Na3C6H5O7. I'm going to have to convert this to moles. The grams come down here, 1 mole. The molar mass, I kind of did the math already. Okay, I'm going to have 23 times 3 of those is 69. We're going to have 12 times 6 of those. Okay, that's 72. That's just going to be 5. And then the last one is 16 times 7, which is 112. Total molar mass should be 258. Okay, so if I take 10 divided by 258, I'm going to get 0.3875 dot 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 dot. Okay, so that's our number of moles. Okay, we know from before that taking 915 milliliters, which is about 32 ounce Gatorade, and making that into liters is going to be 0.95 liters. So if I divide this out, the molarity should be 0.04 molar. Okay, so this is for the entire solution. Okay, so now what do we do with these different ratios? Well, this is a 1 to 3 ratio. So what does this mean? We have 3 times the number of sodium atoms, sodium ions. It's late. Sodium ions here. So I'm going to take 3 times the molar concentration. That's going to tell me how many ions I have here. So my sodium molar concentration is going to be 3 times 0.04, which is going to be 0.12 molar concentration. Okay. So this was a 1 to 1 ratio, so this number is still going to be the same. So for the citrate part, C6H5O7, this is going to be equal to 0.04 molar. Okay. And so this is a way of looking. We might think, oh man, there's going to be 3 times the number, but if I compare this number to what the salt ratio number was, they're pretty darn close. Okay, there's actually a little bit higher concentration number of sodium ions that are kind of floating around, but we take into consideration what the molar masses of these are going to be. But anyway, that's how we do this, guys. The first thing you got to do is find out the molarity, solve for the molarity for the whole solution, remembering to convert grams to moles and any milliliters to liters. I get that number, and then I just compare what my ratios are when I dissociate, when I think about how these things break apart in water, what these ratios are, and that tells me if I need to multiply it by anything, or if it's a 1 to 1 ratio, I don't multiply by anything. If this was a 1 to 2, I'd multiply this number by 2. If it was a 1 to 4 ratio, I'd multiply this number by 4, etc. So I hope that helps, guys, and we'll continue talking about what these electrolytes do in your body here in just a second.
All right, if you take a look at this chart, this is just one example of how sodium and potassium are used in your bodies. Potassium was another one of those compounds, those ionic compounds that breaks apart too. If you remember from biology class, you have a sodium potassium pump, that pumps these things in and out of your cells as needed. But as you can see, this is used. You guys can pause it and read it if you want. About This is all about brain function. Your muscles need these ionic compounds and electrolytes. But now let's really talk about what Gatorade does, though. It is really salty, really, really salty stuff. And unless you are really exerting yourself for hours and hours, you water actually hydrates you better. So it's called the thirst quencher, but it doesn't really quench your thirst. It replaces those salts, but then what it does, it's a little trick to your brain and your body. It makes you have so much salt in your body that after you're done exercising is when you start to drink, and that's when you actually hydrate, because you're going to go later on and drink water, and that actually helps you not to get your muscle cramps and those kinds of things. So it's a little trick that they play with you, saying it's the thirst quencher. Oh, I'm so thirsty, I need a Gatorade. Water is actually better unless you're really, really exerting yourself. I'll put a link to another video about, kind of the history of Gatorade. But anyway, I hope you learned something along the way with just working through our problems there. Miss you guys. I hope everything's going good. We'll talk to you later. Bye.